All right, your test, this, whether I hand them back or not, we'll go over them. Chapter 2. Chapter 2 is going to deal with descriptive statistics. Describes the important characteristics of a set of data. We're going to learn how to organize, present, summarize data, whether it's graphically or numerically. So graphically, we're going to learn a lot of different graphs. Numerically, that's some of the stuff where you do the mean, median, and those range and different things. Important characteristics of quantitative data. Remember, quantitative means that you are dealing with numbers that mean something. Shape, center, and spread. The shape of data, one of the key things for shape of data that we're going to do a lot with is something called a bell curve. So a bell curve looks something like that. And in that bell curve, a certain percentage of the data will always fall here in the middle, and then certain percentages fall in the tails on each side, and we'll talk more about that as we go throughout the year. So that's different data is shaped different ways. It doesn't always have to be a bell curve. There's some data that might be shaped something more like that. Oops, my pen is off. Something more like that, where there's a longer tail on this side and a shorter tail on the other side. We'll talk about that as we go along. The center of the data, some of the stuff that you've dealt with in the past, a representative or average value, median, mean, mode. Those are all things that we consider to deal with the center of the data. And we'll talk more about other things that go along with the center. Variation is how the data is spread out, how it's spread out along the graph or whatever. So you might be on a graph and know that the mean is 5, and we might want to deal with how does it move as it goes out to the right or out to the left. And the spread. One of the variations, one of the spread numbers that you've probably dealt with in the past is the range. The range is the highest minus the lowest, and that's goes right along with this. Distribution. Again, that's the shape. That's what I talked about at the beginning here. Just shows how the data is distributed. So, there's more in this area and less out here in this area. We'll talk about things like bell-shaped, uniform, and skewed. Something like this right here. This one that I draw, this graph that I drew right here, would be a graph that's skewed left because it's got that long tail on the left. So section 2.1, frequency distributions and their graphs. This is sort of, I don't want to say it's hard, but a lot of students have trouble with it, but it's really, really important. We're going to figure out how to construct a frequency distribution, including limits, midpoints, relative frequencies, cumulative frequencies, and boundaries. So we're going to do a frequency distribution, which normally is something like 2 things here. And we'll talk about this on the next one. The first one is classes, and then you have F, which is your frequency, how often each thing occurs. But then what we're going to do is all these other things that I underlined up here, we could put in our relative frequency. And if you start putting all this other stuff in there, then it's called an expanded frequency distribution. Know how to construct a frequency histogram. That's probably the most important graph that we're going to do this chapter. Then all these other graphs also. And this last one here, we decided we're going to decide as a class. I'm not sure how to pronounce that. but we're gonna decide as a class how to pronounce it, and that's how we'll pronounce it all year long. So a frequency distribution is just a table that organizes data, values into classes or intervals along with number of values that fall in each frequency. We'll talk about this here in a second. Ungrouped frequency distribution, all that is if each class just has one number. So each one is like just 2, 3, 4, 5, 6. Grouped, that's more what we'll deal with. Grouped is when you have a class, so you have your classes here, and it might go 0 to 5, and then 6 to whatever, and then so on and so on. So it's grouped together in those certain classes. And we'll talk about that on this next slide. So this is what an ungrouped frequency distribution would look like. Notice that the classes here, the first part is just one number, 1, 2, 3, 4, 5, 6. The second one, this is more what we're going to deal with. Notice 18 to 30, 31 to 42, 43 to 54, 55 to 66, so on and so on. So it's all set up in classes. Now when you do this one, when you do the second one, these classes all have to be the same width. So if you count 18 to 30, and you go 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and you end up with 13, if we count this one, it should be 13 also. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. I think I miscounted. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. I'm only coming up to 12. So let's check this one. Let's check the first one. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So as I'm looking at this, let's count this one. 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. This first one here is messed up because it's 13 and that one's 12 and that one's 12. They all gotta be the same. So I'm not sure why, I'm copied this off somebody and I'm not sure why that's messed up that way. But all the classes have to have the same width. So frequency distribution looks like this, and notice on this one, if we count 1 to 5, 1, 2, 3, 4, 5, that's 5 of them. 5 numbers that are included in that class. And if we go next one, 6, 7, 8, 9, 10, that's 5 numbers. That one's 5 numbers, that one's 5 numbers, that one's 5, that one's 5. They all gotta be that same size. And then you just count up how many is in each of those classes. And we're gonna be given a big long list of numbers. So sometimes you might want to put a third one in here that's a tally, where you're just, for each of these classes, you're tallying up how many fell in that certain group as you go through the list. How many of them fell in there, so like you're keeping score. The first set of numbers, this set of numbers, is called the lower class limit. So down the far left side, that's the lower class limit. The ones on the right are the upper class limit. So you got your lower class limits, you got your upper class limits, and we're going to figure out how to find each of those. And then you have your class width. To find the class width, this is important. Find your class width. You just take any lower class limit minus the next lower class limit, or actually backwards. You take this one minus that one. And we could do that all the way up, and it should come out to be the same thing. You just take any two consecutive ones. And we could do the same thing with any two upper class limits, and it should give us the class width. That's how many numbers fall in that each certain class. So 6 minus 1 is 5, that's our class width for this whole frequency distribution. Lower class limits are the smallest numbers that can actually belong to each different class. Upper class limits are the largest numbers that can belong to each different class. And then the class width, again, that's important. Class width is the difference between any two consecutive lower class limits. It could be any two consecutive upper class limits also. It doesn't make any difference. That's just the easiest way to have it there. Class midpoint. To find the class midpoint, and this is one of the things that as we're making our frequency distributions, we have 2 or 3 columns depending on if we do a tally or not. This is one of the things that we may add on and make it an expanded frequency distribution. We can add on a midpoint, we can add on class boundaries, so on and so on. To find the midpoint, if I look back at that previous, or I'm not even going to go back that far, it was 0 to 5, and then it was 6 to 10, I think. Might have been 1 to 5. I think it was 1 to 5. Yeah, it was. So it was 1 to 5, 6 to 10, so on, so on, so on. To find our class midpoint, we just take the lower class limit, the upper class limit, add them together and divide by 2. So if I was trying to find the midpoint for this class, it'd just be 6 plus 10 divided by 2, which gives us 8. So the class midpoint, if I was going to add that in, the midpoint for that class would be 8, and we just find each one. The class boundaries, and we'll talk more about this later on in this, but all you do to get the class boundaries, because if we're looking at these numbers, 1 to 5, 6 to 10, and if we're like looking at them on a number line or on a graph, we're saying 1 to 5, that goes from here to here, and then we're saying 6 to 10, well, that goes from here to here. Well, all these numbers in here get missed. They're not included in our graph. And we can't have that. Even though those numbers are all decimals and they might not fall on our graph, we can't have that. So a lot of times with class boundaries, we want to include this. So what we do is we come down here a half, or we go up here a half, and we include all those numbers so that everything gets included, even those. And all you do to find that, upper class limit plus next lower class limit divided by 2, and we're actually going to learn a different way to do that later on in this lesson to make it a little easier, but that's class boundaries. This symbol is summation. So if you see something like this and it says summation of x, that means you just want to add up all the x values. You want to add up all the x values. Construct a frequency distribution. Number 1, this is key here. You got to know how to do this. Number 1, decide the number of classes. You're going to be told how many classes they want in most every problem. It's usually between 5 and 20, and actually it's not even between 5 and 20. It's usually something like from 4 to maybe 7 or 8. Because once we get up to 20, that's an awful big frequency distribution, and it's a lot of work. And this says difficult to detect patterns. If you try to separate everything off and just do each number separately, then it's real hard to see any kind of patterns going through all the data. Find the class width, determine the range. Remember, the range is just the high minus the low. So you go through all your data, you find the highest number, you find the lowest number, you subtract. that number goes on top right here, and then we divide by the number of classes that you want. 5, 6, 7, whatever they tell you, number of classes. This, again, this is where most people mess up at. Oops. It's the wrong thing. You always round up, no matter what it comes out. So if we divide it on our calculator and it comes out to be something like 5.0000000001, we still round up. So that means our class width would be 6. We round up to the nearest whole number, or the next whole number. So no matter what, you always round up. Don't go by your rounding rules that you learned for math. No matter what, you round up for your class width. That's, again, finding this, that's one of the hardest things. It's not really all that difficult, but then you find the class limits. We're going to talk about this. You can use the minimum data. So the minimum data, that's going to be the first number in your frequency distribution. So as we're doing this, our classes are here. This number right here, that's the minimum data. You find the lowest number in the data, and that's the lower limit of the first class. Find the remaining lower limits, and the way you do that is add the class width to it. So you find all the lower limits first, then we'll worry about the upper limits. And you do that just by adding that class width to each number and going down the chart. Find the upper limit of the first class. Remember, the classes can't overlap. You're going to find the upper limit. I'm going to show you how to do that. Find the remaining upper class limits. Not really difficult. You're just adding on something each time. Or actually, you don't even have to add on. Make a tally mark for each piece of data. So that's why I said, sometimes you might want 3 columns in here. You want your class. Then you might want a tally so that you can use the little tally marks to count up everything. Then have your frequency. Count the tallies and figure out the frequency. So for this, it'd be like 5 there. That'd be your frequency. So if we have this set of data, the following sample data set lists the prices in dollars of 30 portable global positioning systems, GPS navigators. Construct a frequency distribution that has 7 classes. So they're telling us we want 7 classes. We got all those numbers. Just look at them here real quick. Looks like 59 is the lowest, and it looks like 450 is the highest. We're going to need those 2 numbers. So I got those numbers there. We got 7 classes. That's the first step. 450, 59. We subtract them. Divide by 7. We end up with this, 55.86, and we always round that up to the next number, 56. That's our class width. That's how wide each of our classes should be. Once we have that, the lowest number we had was 59. So in our lower limits, we put 59 in there, and then to find the next one, we just add 56 to that 59, and we get 115. Then we add another 56, and we get this number. Then we add another 56, and we get this number. And we just keep going down that way till we get 7 classes. 1, 2, 3, 4, 5, 6, and then the last one's 7. Next step, to find the upper limits. Easiest way to find the upper limit, the book tells us a little different. Easiest way is just to look at this number. If this is 115, then this limit here has to be 114. It has to stop right before it. If this is 171, then this one has to be 17. If this is 227, then this has to be 226. 283, so this is 282. 339, so this one has to be 338. 395, so 394 goes here. And then the last one, you don't have anything down here to take one off of. So what you can do is just take this number and add the class width to it, add 56 to it. So from here to here, just add 56, and that'll give you that one. And that's what I have all right there. Don't think that this number here is the highest. It's not. It could be a lot higher than any of the rest of the numbers in there, but this time it just happened to work out that it is the highest. The upper limit, they do it a little different on the upper limit. Add class width to get the upper limit. I don't do all that because it's just as easy to look here and go down one. Then you go through your set of numbers and you tally up, and you just have to be careful, going through and counting off each number and marking them into classes where they belong and so on, and just find them all. Once you have all that, once you do all that, then you're just going to write them over here. So this one has a frequency of 5, there was 8 in this one, 6 in this one, so on, so on, so on. That's our frequency distribution chart. Again, the book a lot of times won't put in the tally marks. I don't care if you do or not. That's up to you. I think it's easier sometimes to put them all in there. Summation, again, add it all up. We've already done all that. Midpoint of a class, to find the midpoint of the class, all you do, this number plus this number divided by 2, and we're going to put that right there. Then for the next one, this number plus this number divided by 2, put it right there. This number plus this number divided by 2, put them right there. So on this one, you get 86.5, 142.5, 198.5. Notice when I subtract these two, if I were to subtract them, I get 56. I get the class width. Now where that midpoint's going to come in handy is when we go to make a graph of this. We're going to use that midpoint, so 86.5. We're going to use it to do our graphs. That makes everything a little easier. That's the midpoint. That gets added in, and when we start to make an expanded frequency distribution, you put the midpoints in there and you put all this other stuff in there that we're going to go over. Relative frequency. This is about where we left off. Relative frequency. Relative frequency of a class can either be a percentage, a decimal, or a fraction. We'll probably use decimals most of the time just because they're easier. It's just a portion or percentage of the data that falls in that certain class. So you're just looking at each class and figuring out what percentage falls in that class. And I'm going to say percentage most of the time, but then we'll write down a decimal answer. Same thing, just bumping the decimal 2 places one way or the other. It's easier for me to explain it to you to say this is the percentage that falls in that range, and then it's easier for you to write down the answer as a decimal. Have your calculators out so you can help me here in a second, so that we can figure out these percentages. Find my calculator. Relative frequency is another one of those things that can be added on to make it an expanded frequency distribution. So to find the relative frequency for each one of these, all we do is we take this number, the frequency, and we divide it by how many there are total in the whole group. And I can't remember on this if, looks like since they got a dotted line there, probably using the whole group. Let's see what it says here. Yeah, there was 30 in the whole group. So you take the 5 that's in this, divide by the total, which would have been down here somewhere. The sum of all of them here would have been 30. 5 divided by 30 and we get 0.17. That's the relative frequency, the 0.17. If it makes more sense to you to make that a percentage, then put in 17%. All right? Now you got to be careful with this. What percentage would this be? Now here's where you got to be careful. What percentage is this? 20%. Just make sure you don't forget that.
For it to be 2, it would be 0, 2, right?
Right, it'd be 0.02.
Yeah.
So just looking at those percentages, what do we know about the second class? Give me some inference you can make about, or the first class, I mean. Give me some inference you can make about this first class. Is that more or less, same, what?
Less than last time.
It's got less than the others, it seems like, right? So just something like that, that's all you need. And we could do that for that whole thing. I don't know if the next slide does it for the whole thing or not. But then you have the relative frequency. And you got to be able to, the percentage, I probably would never write them as a percentage because it's just more writing. That's why we usually write them as decimals.
So we can leave them as decimals.
Yep. But you need to be able to understand, hey, it's 0.17, but that means it's 17%. That way, you don't have to do quite as much work as long as you can understand it in your head. Because when we do other stuff with the relative frequencies, it's going to make more sense if it was a percentage. Cumulative frequency, this confuses the crap out of a bunch of students, and it's probably the easiest thing. I'll give you a second. I'm not sure why it's confusing, but how do we pronounce that word, Lily? No, the word that I told you last time.
Ogive.
What is it?
Ogive.
Ogive? Alright. So make sure. So we use this to make an ogive. We'll get to how to make those here in just a minute. cumulative frequency is you're picking a class, and we want to know what's at that class and below it. So if I pick this class, the first one, how many people are at that class or below it? Just 5. To get the next one, all we do, take these two, add them together. So this next number right here, 13.
So the frequency, the,
Cumulative
for
frequency.
the first one, it'll be the same?
It'd be the same as whatever that class is. And then as we go down through it, you're just adding on the next one. So from here, we add on that 6 and we get 19. And then as we go down, say we get all the way down to the bottom, the very last one, this is the very last one, since I don't have the whole chart up here. We already know that that very last one should be the same as the total number of pieces of data that we had in our set. In this case, it was 30. So once we get down here, all these, once we keep adding on, that last one right there should be 30. If it's not, then we screwed up adding somewhere or counting or whatever. So that last one should be how many total pieces of data we had in all the numbers. So the whole set. That's all cumulative frequency is, just adding the next one on each time. So an expanded frequency distribution might look like this. This has some of the stuff on there that we could expand it out to. You got your class, you got your frequency, you got the midpoint of the class, you got your relative frequency, you got your cumulative frequency. We could also add on more stuff. One of the things that we could add on would be class boundaries that we're going to talk about here in a minute. Notice here, this one, make sure that they add up to 30, or however many pieces of data you have. This one, if we add all these up, those are percentages. What should all those percentages add up to? 1 or 100 if it was a percent, right? Now, it's probably not going to be exactly 100 because you're going to round it off, and it's not going to come out exactly right. But if it's coming up 105%, you better check it because you're doing something wrong. If it's coming up 101% or 99%, we're probably okay. We just rounded too much one way or another. And there's more stuff that we could add on to make this even, more expanded. Frequency histogram, very, very important, the frequency histogram. Probably the most important graph that we'll deal with throughout the year. To make a frequency histogram, you might want to do this. It's not really, probably not an appropriate way for me to do that, but I was probably too lazy when I was typing it. Because it's not a bar graph.
What is it called?
Histogram.
Oh, that's
difference between a bar graph and a histogram. A histogram, the bars have to touch each other. They have to touch. A bar graph, bars shouldn't touch.
Do we know why?
I'm getting ready to tell you.
Okay.
When you're doing a bar graph, usually a bar graph will have something along the bottom, and it usually won't be numbers. If you see a bar graph, if I told you to get out your computers right now and look up and find a bar graph, the bar graph might say something like this: freshmen, sophomores, juniors, seniors. When we do this, should these two bars touch?
For what? Instagram or a bar?
For a bar graph? I mean, just looking at this, does it make sense for them to touch?
No, they shouldn't touch.
No, because there's completely
They're different things.
two complete different groups. That's a bar graph. Bar graphs usually have categories down here of some kind. Histograms have numbers along the bottom. Now, if you do this, for a histogram,
It's wrong.
That's technically a bar graph.
that's telling you that those numbers there on that number line, are they part of our stuff that we're dealing with?
No.
No. So that's why the bars touch. The bars touch because we want it to be continuous. So this goes from like 0.5 to 1.5, and then this one goes from 1.5 to 2.5, and so on and so on. But it's got to be continuous. So that's a histogram. A histogram has to be a continuous. The vertical scale, that's the up and down. Vertical scale, Isaac always remembers vertical because he knows his vertical leap is like 13 inches. So vertical, up and down. Horizontal, the horizontal is the data values. That's where the midpoints or whatever that we decide to put down there is going to go. Consecutive bars must touch. Consecutive bars must touch for a histogram. Class boundaries. Easiest way to figure out class boundaries. Subtract 0.5 from the lower limit. You might want to write that, lower limit of each class, and add 0.5 to the upper limit. Sorry, my pen is writing out a whole lot higher than I wanted it to. And all it does is it takes care of the gaps, so there are no gaps in there, so that the bars can touch. On the other ones, it said take the lower limit, the upper limit, add them together, and, or no, it said take the lower limit, upper limit, subtract them, and divide by 2 or something. That's crazy. That's too much. You're just going to do this. So if we wanted to class boundaries, the one that we were doing, I can't even remember what they were. We'll look at something here in a second. When I show you how to do it, class boundaries are easy. It's another thing that could be added to your frequency distribution to make it even more expanded. So if I have this, all I'm going to do, I know they tell a completely different way. All I'm going to do this to get the class boundaries This lower limit, just take half off of it. So 58.5. The upper limit, just add half to it, 114.5. Down here, 114.5, 170.5. Notice now, those are the same. This next one, this is gonna be 170.5. So now that one's the same as that one, and our upper class boundary would be 226.5. And all it does is it makes it so that when we're putting something on a number line, it's not leaving any gaps. Everything's touching. So the class boundaries for our big chart that we had there would look something like that. Making a frequency histogram. We're going to make a frequency histogram of this stuff. I'll show you how to do it. Let's write this down on the side here somewhere. We're starting at 59 and we're going up to 450. Our class midpoints, 86.5. Somebody help me out. Write down the frequencies. Just in a little column there in your notes somewhere, just off to the side. 86.5, 142.5, 198.5, 254.5, 310.5, 366.5, and 422.5. These are the midpoints. If I'm making a histogram, I'm always using the midpoints. I'm never ever using the class boundaries. It's just more writing. And we don't want to do any more writing than we absolutely have to. Oh, they already made it. We didn't need to. So this is what it looks like. Couple things on this. I thought we were going to make it. Notice the midpoints, just right in the middle of the bars. Then all you do for the first one, for this first class, there was 5 of them, right? That was the frequency was 5. So you just draw in, got your 2, it went by 2s this time to make it even a little easier to write. 2, 4, 6, 8, 10. Well, this one had 5, so we draw a bar with that right in the middle, goes up to 5. Next one was 8, we draw a bar. That midpoint right in the middle, it goes up to 8, the bars have to touch. Make sure you realize this tells you that you're starting at some other number other than 0. So when you're making your graphs, you draw that and do this. Put that little Z looking thing in there. Just tell everybody, hey, we're not starting at 0. So it's like it got smashed in. And then we just go on out. Now this is our histogram. What's something that we can tell from this histogram?
Most of them are price that
All right, so most of them, the highest number is about $142.50, right? Or the one that's priced has the most in that price range is that. What else can we tell from this histogram? There's only one that's at that price range, right? What's the highest price?
$422.50.
And we can tell that most of the GPSs are priced less than what? About?
Less than 300
Probably
somewhere.
310, right? They're priced less than that right there, somewhere around they're priced less than $300. So if we go out and we're gonna buy a GPS and it's $600,
That's bad.
It's probably not a great deal.
Imagine buying $400
No wonder I put the blank slide in the wrong spot. That'd be fun. If we were to use the class boundaries, notice now we got boundaries at the sides of each one. And it's not that much more, but there's like 2 extra numbers there that we have to write. So I would rather use the midpoints than the class boundaries. That's up to you. If you want to use the class boundaries, just know boundary goes here, this side of this bar, this side of that bar, so on and so on, all the way across until we get to the end. Still means the same thing. Same graph, just sort of represented a little different. Frequency distribution, frequency polygon. Frequency polygon is a line graph that emphasizes the continuous change. I'm not going to expect that Riley has all this memorized, as long as she's got it written down in her notes there, and she looks back at it and goes, oh, that's all I do. None of this is real difficult. It's all pretty easy. The hardest thing is making the frequency distribution table. If you understood that at the beginning here, then this is all real simple. Hardest thing is knowing where to look back in your notes probably and say, okay, how do I make a frequency polygon, and finding it. What can you tell me about that graph that I have drawn there?
The data values
What's it look like it's happening?
it's going down.
It peaks
Like,
and
it peaked and then it went down.
That's what it looks like, right? So it looks like, hey, we went up and we got to this point, and then all of a sudden we start going back down. And that's what's good about a frequency polygon. Line graph that emphasizes a continuous change in the frequencies. So it shows you how it changes across the classes in the different, or how many is in each of those classes as you go across. So if we're going to construct a frequency polygon for this, Isaac, you still got those numbers written down there?
yeah.
We'll use them here in a second. Because I think I did this one right. Okay. So all we're going to do is this. Our frequencies went from like 1 to 8 or something, right?
Yeah.
So on our side over here, we want to put in numbers. On the last one, they went by 2s. Let's go by 1s this time. So we'll make that 1, 2, 3, 4, 5. When you're writing in all these numbers, 6, 7, 8, 9, 10, you don't have to write in every number. Just something like that, that'll work. Along our bottom, that's where we want our midpoints. 86.5, 142.5, 142.5, like it right. 198.5, 245.5, 310.5, 366.5, 422.5. Braden's noticing that as I make this, how perfect all my lines and everything look. Yours better look at least that perfect. They don't have to be spectacular is what I'm trying to say. Over here, we're always going to label this as our frequency. You can abbreviate a little bit there. That's your frequency. Along the bottom, this was price of GPSs. Make sure you're labeling stuff. The first one was 5, right?
Yeah.
So we put a dot right there.
And then 8,
Be right about there.
6.
It's hard for me to tell these up here. Right about there.
And
5 again. About like that.
2.
2. Up there.
1.
Up there.
And then
3.
3. Yep.
About like that. Now, what you got to remember with a frequency polygon, if I connect all these, did I make a polygon?
Still showing.
So what has to happen here, it has to be closed. Somehow we have to close this up. And what we do is we go up 1 from here and we go down 1 from here. So let's see, what was it, 56, was that our class width? What's 422.5 plus 56?
Or
478.5. How many GPSs did we have that sold at $478.5? So we put a 0, we put a dot right there. Now on the other end, we do the same thing with the 86.5. We come down 1 more, and I should have done this at the beginning instead of at the end. So what's 86.5 minus 56? 30.5. How many did we have selling for $30.50? We connect those. Now we have something that's closed in here. That's our frequency polygon. So the way it looks here, you have several that are down here on the cheap end. Then there's not a whole lot that's in the middle here. They start going down. Then you have a few that are really, really on the high price end. So that's a frequency polygon. It looks like that, if I could draw a little better. Relative frequency histogram. Relative frequency histogram. Again, if it's a histogram, what's going to be true about the bars? They got to touch. Confused so far, Lily? I don't know about that, but hopefully you won't be confused later. Anybody see anything that I forgot to do on that last graph? Should've,
Oh, yeah.
should've put that in there. Wish my pen was recalibrated. We just talked about a histogram a few minutes ago. This histogram and this relative frequency histogram are going to look identical to each other, except the histogram has the frequency, so like 1, 2, 3, 4, 5, 6 along the side. The relative frequency along the side, the vertical axis here, has a decimal or the percentage. So they're exactly the same thing, it's just changing that vertical axis. And the reason we do that, if you go home and you tell your parents tonight what you were dealing with, what form is easiest for your parents to understand? Decimal, fraction, percent, or just a regular number? Probably a percent. Alright, that's, for whatever reason, in the world that we live in, if you hear a percentage, you have some idea what that percentage means. If I just told you 5, there was 5 in that group, is that gonna mean anything to you? Right. But if I tell you it's 17%, then all of a sudden it makes a little more sense to you. So that's why we might want this relative frequency histogram instead of just a regular histogram. And the only thing that's different again is that vertical axis going up and down. I'll tell you what, I ain't even gonna make this. You guys can understand this, right? So we got the relative frequency out here. Remember that this is 20%, that's 10%, that's 3%, that's 7%. Well, it's gonna make it, but I'm just gonna skip it. And that's all that changes. This side right here, when we made the histogram earlier, it looked just like this. Except out here we had 1, 2, 3, 4, 5, 6, so on and so on. Or actually they had 2, 4, 6, 8, 10. So it's the exact same thing, just puts decimals or percents over here. You can put whichever one you want, I don't care, the book will normally put decimals. Percentages might be a little easier. Cumulative frequency graph, or a what? What is it? You guys, ogive? Or you said it different than, never had a class say it that way before, so now it's gonna confuse me all year long. Shouldn't be good, because if I'm confused about that, that might make it harder for me to teach you what. I might confuse you about other things.
What do you call it other places?
I don't have any idea. I told you I didn't know how to pronounce it. That's why I let you pronounce it.
What are your other classes?
They didn't say ogive. I don't know. Ogive, ogive. How else did they pronounce it? Not sure, but I bet this is one of the few things in math that some math person was being an idiot and gave it their name. You don't see that very often. It was probably some scientist, because scientists do that all the time. Everything's their name. So an ogive, on an ogive, all it is, it's a line graph. Notice, it's not gonna do the same thing as the polygon. It's never gonna come back down. It's just gonna keep going up. And as it keeps going up, whatever this last one is right here, that should be the total number of pieces of data that you have in your entire set. Nothing hard about making an ogive. It's real simple. You're just accumulating the stuff as you go. I don't even want you to write any of this down. Making an ogive is just real easy. You're going to construct the frequency distribution, specify the horizontal and vertical axes. Vertical scale is cumulative. Nothing hard about this. Plot the points and connect them. We'll make one of these here just real quick. So we got, if we do our cumulative, we got that, we got 5, 13, 19, 24, 26, 27, and again, notice the last one has to be the total number of things in there. Go ahead, Michael, you're not going to talk. So if I'm making this ogive, remember to put that in this time. We use our midpoints, 86.5, 142.5. Is it gonna bother you guys if I don't write all these numbers down? So 1, 2, 3, 4, 5, 6, 7. And that seventh one is the 422.5. Now over here on our side, this is our cumulative frequency. So that's the frequency as we add it up. So I can't just go 2, 4, 6, 8, 10, because as we go through adding this up, we know we're going to get to a total of 30. So we might want to go something like 5, 10, 15, 20, 25, 30, 35. And you're just going to put each one at 86.5, there was 5 GPSs at or below that. At 142.5, there was 13 GPSs at or below that. Then 19 at the next one. Then 24. Then 26. Then 27. Then 30. Probably too high. And then all we're going to do is connect them. What, again, look at this. What's it tell us? It's what happens in this range.
Kind of gets real close together and flattens out.
Flattens out, doesn't it? Why does it flatten out there?
There's not many for sale.
Right, there wasn't many for sale at that price range. Alright, so it tells us that, hey, it flattens out here. Goes up pretty quickly, and there's quite a few here, quite a few here, quite a few here. Then we get to here, and it about flattens out because there's not a whole lot, and then here at the end, well, there's a few more that are the higher price ones. And down here at the bottom, again, I should have put, you gotta label your horizontal axis and your vertical axis, price of GPSs, something like that. Hopefully theirs looks about the same as mine. You can see that about 25 GPSs cost $300 or less. So they're saying that from $300 or less, that's somewhere about there. About 25 of them down here, and that means there's only about 5 of them up here. Come up here, grab one off each of these piles. We're going to do these two together real quickly. Just making a frequency distribution chart. So we got this. First thing we're going to do, class. Find our class. Looking at that first set of data. We need the highest and the lowest number.
The lowest is 30.
30 is the lowest.
No, 300.
300. Subtract those two. What's that give us?
270.
270. How many classes they say they want on the first one?
6.
6. So we take 270 and divide by 6. Somebody help me out. 45 even?
Yeah.
Now, when this happens, which it won't happen very often, that's supposed to be 45. It won't happen very often. We still want to round up. All right? So from 45, we're going to jump to, that's our class width. Our class width is 46. We know we got 6 classes, so there's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What's our first number going to be right here? And this is the most common place where people make a mistake. If you understand all the rest is, this next thing is where they make, or most mistakes are made. We go 30, we got our class width is 46. We're going downwards, we're not going across. So what's 30 plus 46?
76.
That goes there. And 76 plus 46?
122.
122 plus 46?
168.
168 plus 46?
214.
214 plus 46?
260. And 306.
Isaac wanted to keep going, but we only needed 6. Used to be on the old junk calculators. If you get one of those little bitty ones,
Yeah.
you just keep hitting plus, and it'll keep adding the same thing over and over again. And then Michael shaking his head like, yeah, I remember that, because he was probably in 2nd grade, and his teacher gave him one, and he sat there
Pretty nice.
pushing the plus button over and over again.
I noticed that.
Watching it go up.
Yeah, I think I hold.
How do we find this upper limit?
It's just
The next
75.
number,
Look down there.
121,
67.
213, 259.
Now this one, we take 259 plus 46.
Which is 304.
So the last one you had the class with? That one?
Right, you add the class width to that,
Yeah.
because we don't have another number to go off of down here. I didn't put this on here. I probably should have. Let's go ahead and we'll extend my thing out. We'll put a tally. I put a tally on yours. I probably didn't, did I?
Yeah, there's.
Oh, yeah. Oh, so I didn't need that extra. So we're gonna tally them. All you're gonna do is you're gonna read off the numbers to me, and I'm gonna figure out where they go. Stick them in here and tally them up.
105. 287. 294. 300. 228. 215. 223. 280. 550.
What is it? 50.
Just 50.
50?
128. 208. 100. 166. 97. 64. 30. 241. 203. 282. 295. 133. 268. 122. 240. 95. 38. 290.
200.
Yeah, 290.
290.
217. 76. 183. 235. 295. 101. 249. 214. 53. 252. 254. 86. And 114.
Once we have the tally, then we want the frequency, which is just F. What's the frequency in that first one? Yeah, I forgot. She probably figured I'd forget. Yeah, after she wants you to stop down before you leave the numbers, whatever.
Alright.
So that's 5. Next one.
8.
Next one.
4. 3. 11. 8.
9.
Now, this column I always like to add up to make sure. 13, 20, plus another 20, it looks like 40. Somebody count Was there 40 numbers in that set? 1, 2, 3, 4, 5 across, then 1, 2, 3, 8 down, so 40. So that means we didn't miss any. Next thing, class midpoint. All we're gonna do to get the class midpoint, add these two together and divide by 2. What's 30 plus 75? Divided by 2,
52.5.
now we could continue to do that. It's probably easier. All we really have to do to get the next midpoint, next one, add 46 on each time. So you got 52.5 on your calculator, add 46 to that,
98.5.
and then add another 46 to it. What is it?
144.5.
And then add another 46 to it.
190.5.
And then another 46,
236.5.
and another 46.
282.5.
Next one, class boundaries. Class boundaries, all you do is, it's gonna look like this here, except this one's gonna go down by a half, this one's gonna go up by a half. So this would be 29.5 to 75.5. Next would be 75.5, and it goes up to 121.5. Next would be 121.5, and it goes up to 167.5. Can you guys fill in the rest without me filling them in? I didn't make my box big enough. Relative frequency. All you're going to do is take the frequency and divide it by the total. Somebody help me out. What's 5 divided by 40?
0.125.
I'm not going to write the rest of them down. I'll write down the decimal answer, but what's 8 divided by 40?
Wait, where do you think, where do you decide?
Take the frequency
Yeah,
and divide by the
okay.
total.
The 0.1.
4 divided by 40, 0.1.
0.05.
0.05.
0.2.
You sure that one was right?
Oh, 0.75.
I don't know, it's not right either.
3 divided by 4.
Yeah.
Point
0.075.
0.075, that sounds a little better. How'd I know that that probably wasn't right, other than I'm a math teacher? I look here,
So that's 1.
that's 10%, right?
Yeah.
If this was 5%,
That don't make sense.
it'd have to be half of it, wouldn't it?
Yeah.
So that, how about 11 divided by 40? 0.275? And then 9 divided by 40?
0.225.
What should all these add up to?
1.
They should all add up to 1. I would guess that they do. And I didn't put this one on there. You could add another column to it. I should have put it on there. Cumulative frequency. All you're doing, what's the cumulative frequency from here down? How many have we had so far at that point? 5. Then you just take that, add this onto it. What's that give you? 13. Then you add that onto it. 13 plus 4,
I'll tweak.
17.
Oops.
17 plus 3,
20.
31. Plus 9. What should we end up with there at the end?
40.
Our total. Expanded frequency graph. That assignment, same assignment as you got when the sub was here. You should be able to do it now though, right?